Good afternoon. Okay, so the last day we had started doing these calculation questions using all of our different formulas. So we've 3 different formulas now for acceleration. So we didn't finish this one, so I want to finish this one and I'll do one more and then I'll give you a couple to do and then that's it for the calculations. And then hopefully tomorrow I should be in tomorrow, hopefully, and we'll be able to do the practical. Okay, so this question had 2 parts. The first part was with what speed does the object hit the ground? So I have that there. So I hadn't 100% finished it, but the final speed, or the speed that it is going at just before it hits the ground, is 24.24 meters per second. Yeah? So this over here was my list of variables. So now that I know the ending speed, I can kind of cross off that and call it 24.24. Okay, because it might be helpful now that I know it. The second part, the one that's highlighted in yellow, was how long does it take to reach the ground? Okay, so how long we've highlighted down here is time. So I have a couple of formulas. The middle one is not going to work because there is no time in it. So it's going to have to be the top one or the bottom one. And the fact that in the bottom one the time is squared, I wouldn't choose that unless I had to. Does that make sense? Because you're going to have to solve a quadratic, and like, why would we do that if we don't have to? So I'm going to choose this top one and see if this will work for me. Sometimes you can't really tell till you write it down. So I'm going to write it down. A equals V minus U over T. Okay. Now I know this is hard when it's not all on the same page. Maybe you can just about see that. So do we have A? Hopefully you can see that it's right at the bottom. It's 9.8, so we do have A. Do we have V? We do now. It's 24.24. Do we have U? Yep, it's 0, so we have that. And do we have T? No. Okay, I have it written there. Is it solvable? Question mark. It will only have one missing variable. So if it is a solvable equation, then there will only be one variable that you don't know. And if you look at my little situation here on the right, the only one of these that I don't know is T, so that means it is solvable. Okay, so we'll put our numbers in. So it's 9.8. V is the 24.24 that I just calculated. U is 0 over T. Okay, do any maths you can do. So 9.8 equals 24.24 over T. Now, when the thing you're looking for is on the bottom, it's always awkward because we want to isolate it, but we also want to get it off the bottom. So you kind of have to get it off the bottom first and then isolate it second. So at the moment, the 24.24 is being divided by T. Yeah, that's what that line in the middle means. It's being divided by T. So to undo that, to cancel it out, we need to multiply by T. The multiply by T will cancel out the divided by T. But if you multiply by T on the right, you need to multiply by T on the left. Okay, so T times 9.8 is 9.8T. And everything's gone on this side except the 24.24. Then I want to still isolate the T. At the moment, that T is being multiplied by 9.8. So to undo that, I divide by 9.8. That cancels out the 9.8 and isolates my T. But if I divide by 9.8 on the left, I have to divide by 9.8 on the right. So that gives me 24.24 divided by 9.8 is 2.47 seconds. And that's my time. Okay? So that's that one finished. And we'll have a quick look at this one just because obviously I did that in 2 parts. So an object falls from the top of a building and strikes the ground 5 seconds later. Find the height of the building. Okay, so what did I figure out it was the other day? You've asked, wasn't it? Whoop. So U equals V equals A equals S equals T equals. So these are all our possible variables. So an object falls from the top of a building. Again, we're assuming that if it fell from the top of a building, it was either like sitting on the top and just kind of rolled off, or someone was holding it and it was dropped or something like that. So its initial velocity, or its initial speed, U, is going to be 0. The final speed, I don't think I have. No, I don't have. Don't know if I need it, but at the moment I definitely don't have it. A, again, there's no number there for, but if this object is falling, then what's the acceleration acting on it? So the acceleration acting on it is gravity. So that's 9.8. S, remember S is the distance. And they're asking us here for a height. A height is just a vertical distance. So that's actually our question mark. That's what we're trying to figure out. And the time we are given, it says that the time is 5 seconds. Okay, I'm going to put these formulas here just so we can choose one. No, that's wrong. Good start. So A equals V minus U over T. A equals V squared minus U squared over 2S. And S equals UT plus a half AT squared. Okay, so the first two were the ones that I taught you when we were learning about horizontal acceleration. The first one being if you're given the starting speed, the final speed, and time. And the second one if you're given the starting speed, the final speed, and distance. And then the last one is the new one for this experiment. S equals UT plus a half AT squared. Okay? Right, so what one is going to work? I'm trying to find S. So S is my question mark. Which means that top one there is out because it doesn't have an S. I'm not going to eliminate it just yet because I might need to kind of double up. Right, let's do ticks on the second one. So I have acceleration. I don't have velocity. I have initial speed or starting speed, and I don't have distance. So that's not going to be solvable because I have two X's. So let's go down to the next one. I don't have speed, or distance. I'm trying to find it. Do I have U? I do. I have T. I have A, and I have T. Okay, so it's that one. Brilliant. Okay, so we've got our formula, which is great. Sometimes you have to kind of use a combination of two formulas, but much easier if you don't have to. I'm just going to zoom out but try and keep the constants there. Okay, so S we don't know. U is 0, T is 5, plus a half is a half. A is 9.8. And T is 5 again. Yeah, so just type all that in. Just directly into your calculator. There's no algebra needed here because the thing we are trying to solve for, the distance, is already isolated. So we don't need to do any algebra, which is always handy. So I am getting a distance of 122.5 meters. So that's the height of the building. So there you go. That is exactly what you need to do for all of these questions. So you write down your UVAST and you put down what you have, what you don't have, what you need. So I would differentiate between, do you see the way for ending speed? I just said I didn't have it. Whereas for distance, I used a question mark because that means I need it. Do you know what I mean? So obviously we don't have the distance either, but don't put it in as an X, put it in as a, I don't have it, but I need it. So it goes in as a question mark. Once you have your UVAST quantities written down, get your three formulas in one place and do exactly what I did there. So I need distance. So this one is not looking good because it doesn't have an S in it. So I kind of skipped over to the second one. I went through the second one bit by bit by bit, each one asking myself, do I have it, do I have it, do I have it? The fact that I have 2 x's in it means it's not solvable. So then I moved on to the third one, and thankfully the third one worked fine. The only unknown, or the only quantity that I didn't know, was S, which actually worked out really, really well because I didn't even need any algebra, so very handy. Okay, so tomorrow hopefully I'll be back in and we will do the experiment, the acceleration due to gravity experiment. But for today, I'm going to give you a couple of these questions. I just want you to work through it just like I did there. So filling in your UVAST, looking at your 3 formulas, deciding which one to use, and then attempting to do the maths. So today is Wednesday, actually. Sorry, I need a new page because it's December. Shh. So Wednesday, the 1st of December. So there's the first question. So there's the first question there, the first 2 questions. So the first one you've been asked for how long, which is a time, and the second one with what speed does it hit the ground? So that's your finishing speed or your ending speed. So there's 2 things to figure out there. And the second one, we're looking for height. Looking for greatest height. Actually, that's one, sorry, I need to give you a little bit of background on that one. So just because it didn't come up in one of the questions. The greatest height is, so if you imagine something being thrown upwards, you hold something in your hand, you throw it up. It will, based on how much force you give it, it will go up and up and up and up and up. I'm so sorry. I'm so sorry about that. So the greatest height. Right, so you take something in your hand, you throw it upwards. Depending on how much force you give it, it will travel a different distance up. But regardless, because we have gravity, and gravity doesn't like things traveling up, it wants it to travel down. As it travels up, at some point it's going to hit its greatest height and then come back down, right? So at the greatest height, so when it reaches that greatest height, for a moment, it stops and then it falls back down. So because it does that stopping, the final speed, just for a moment, is 0. Does that make sense? So I throw something up, I give it a force, so it gets an initial speed from my hand. It travels up and up and up and up and up, losing speed all the time. And then when it gets to the top, its final speed at that moment of the greatest height is 0. Okay, and another thing, you're probably fine with this, I think we might have talked about this, but just in case we didn't. When something is traveling vertically upwards, it's going against gravity. So the acceleration for something like that is still 9.8, but it's minus 9.8, because remember when we were doing deceleration, it's negative. Okay, so they're just a few little bits that might catch you out. I did have one more. From the ground reaches 100 meters. There, 6. Sorry, I knew I had 3 that I wanted you to do. So there's the 3. All right, so go back and look at my 2 examples that I did. Do it in the same way. So write down your UVAST, fill in your quantities, write down your 3 formulas, do the ticks and the X's to figure out which formula will work. Remember, you can only solve a formula if there's only one thing that you don't know. And give these 3 questions a go. All right, and we'll do the practical tomorrow. All right. Thanks, guys. Chat to you tomorrow.